Nyla started to draw a small and a large robot. Help her make the large robot a scaled copy. Which lengths on the large robot would you change? On the small robot, we have 5, 8, and 2. On the large robot, we have 15, 20, and 5. 5 times what equals 15? Well, 15 divided by 5 is 3. So 5 times 3 is 15. 8 times what equals 20? Well, 20 divided by 8 is 2.5 or 2.5. So 8 times 2.5 is 20. 2 times what is 5? 5 divided by 2 is 2.5 or 2.5. So 2 times 2.5 is 5. So we can see here that the height is multiplied by 3, but the width and the antenna are multiplied by different factors of 2.5. To make this a scale copy, all of these values must be multiplied by the same factor. There are a few things we can do here. If we want to make the scale factor 3, we can leave this relationship of 5 and 15 with the height and change the width and the antenna. Five times 3 is 15, 2 times 3 is 6, and 8 times 3 is 24. Now we have a scale copy of the robot with a scale factor of 3. Another thing we can do is change the relationship of the height so that the relationship has a scale factor of 2.5. So 2 times 2.5 is 5, 8 times 2.5 is 20. We're going to change the height. So 5 times 2 is 10, and half of 5 is 2.5. So 5 times 2.5 would be 12.5 or 12.5. Now, every value on the small robot has been multiplied by 2.5. Our scale factor is 2 and 1/2. We could have also written this as 2.5. Another thing we could do is change all of these values to the scale factor of our choice. Let's say we want a scale factor of 2. Well, 5 times 2 is 10. 2 times 2 is 4. And 8 times 2 is 16. We now have a scale copy of a robot that has a scale factor of 2. Just for fun, let's see what it looks like to make the scale factor 1.5 or 1.5. So half of 2 is 1. So 2 times 1.5 is 2 plus 1, which is 3. 2 times 1.5 is 3. Half of 5 is 2.5. So 5 times 1.5 is 5 plus 2.5. That's 7.5. Half of 8 is 4. So 8 times 1.5 is 8 plus 4, or 12. 8 times 1.5 is 12. We now have a scale copy of a robot with a scale factor of 1 and 1/2. We could have also written this as 1.5.